The purpose of today's discussion is to understand how the net positive suction head, that is NPSH, available is calculated, and this is required to ensure that NPSH available is more than NPSH required for the pump. So let's start the discussion. How the net positive suction head available is calculated. So following is the points where the net positive suction head is dependent. Point number 1 is atmospheric pressure, that is PA. This is called the main driving force to push the liquid into the pump suction. Point number 2 is a reservoir pressure. It can be vacuum or it can be blanketed. In case of vacuum, reservoir pressure is considered negative. In case of blanketed, it is considered positive. So PR can be negative or positive depending upon whether it is vacuum or it is a positive blanketed. Point number 3 is static height pressure. If pump location is above the reservoir, then it is considered as a negative. If pump location is below the reservoir, it is considered as a positive. Point number 4 is suction velocity head pressure, and it is always considered as a driving force, so it is always positive. Vapor pressure of the liquid at that operating condition is considered negative. And all the pipe and fitting losses, including the strainer losses, are considered negative. So point number 1 to 6 we have to consider for calculation of NPSH level. Atmospheric pressure, that is PA. Normally atmospheric pressure is taken as 1.013 bar absolute, and as I said, it is a driving force, and so it is considered as a positive for calculation of NPSH. Reservoir pressure, that is PR. Vacuum, in case of vacuum pressure, put negative sign for the calculation of NPSH, and for positive, that is blanketed type, put positive sign for the calculation of NPSH. Pump, that is a static height pressure, P. Pump is connected in reservoir in two ways. This is one way. Pump is above the reservoir. You can take the case, reservoir is here, pump is above the reservoir, and so put the negative sign for static height pressure for NPSH calculation. So H is considered negative. For the other side, pump is below the reservoir, and so H should be positive. So pump is below the reservoir, put positive sign for a static height pressure for NPSH calculation. Velocity head pressure, that is PV, is the velocity head pressure is added, that is considered as a positive sign for calculation of NPSH. Vapor pressure, PVP, vapor pressure is minus, that means negative sign for calculation of NPSH. Piping friction loss, including the strainer pressure loss, that is PF. Pipe and fitting friction loss, including strainer loss, is considered minus, that means negative sign for the calculation of NPSH. So in summary, net positive suction head, that is NPSH available, is equal to barometric pressure plus reservoir pressure plus static height pressure plus suction velocity head pressure minus vapor pressure minus piping and strainer head loss pressure. So we can write NPSH available is equal to PA plus PR plus P plus PV minus PVP minus PF. However, the net positive suction head NPSH required is provided by the pump manufacturers, and we need to ensure that the net positive suction head available should be more than net positive suction head that is NPSH required for proper operation of the pump. Typically, 0.20 bar gauge as a safety margin is considered for sizing of pump as well as the piping for safe operation of the machine. Now let us understand how we can calculate the NPSH available using an example. So pump is installed above the oil reservoir at a vertical height of 2 meter through 4-inch schedule 40 welded steel pipe, that is inside diameter of pipe is 4.26 inch. Pipe is straight vertical, so length of the pipe and height is same, with one ball valve, which is one ball valve, and one suction stand, this is suction stand installed. 400 LPM, it is LPM, M is missing here. 400 LPM oil is flowing through suction of the pump through pipe. Density and viscosity of oil at operating temperature is 850 kg per meter cube and 32 cp respectively. Oil reservoir is in vacuum of 100 mmWc, millimeter of water column. Vapor pressure of oil is considered 0.05 mmWc. Pressure drop in suction strainer is 0.02 bar gauge. Calculate the NPSH available with pump. So this is the problem. Now we have to calculate NPSH based on this information. Now solution. Point number 1. Atmospheric pressure we know PA is equal to 1.013 bar absolute. Reservoir pressure is 100 mmWc is vacuum. So the P is equal to density of water into G into H. That is minus because it is vacuum. So density of water is 10 to the power 3, that is 1000 into G 9.81 into 100 into 10 to the power minus 3 is for converting meter, and now divided by 10 to the power 5 to converting bar gauge. So on calculation PR is equal to minus 0.010 bar gauge. Static height pressure, that is P is 2 meter, so it is oil, so density of oil into G into H. So again it is vertical, pump is above, so minus 850 into 9.81 into 2 divide by 10 to the power 5 to converting bar, so it is now bar. So on calculation it is coming minus 0.17 bar gauge. Velocity head pressure PV. Actual flow we know 400 liter LPM, that is multiplied 10 to the minus 3 is becoming meter cube, divided by 60 is meter cube per second. So Q is equal to 0.0067 meter cube per second. Pipe inside diameter D is 4.26 inch. So cross section area is pi into D, converted into millimeter, divided by 1000 is meter. Now square upon pi by 4 D square. So it is meter square. On calculation it is coming area 0.0092 meter square. So velocity in pipe is Q by A is equal to 0.72 meter per second. Velocity head is equal to V square upon 2G, which is coming as 0.027 meter. So velocity head pressure is equal to density of oil into G into HB, which is coming as 850 into 9.81 into 0.027 upon 10 to the 5 is again converted into bar gauge. So now P is 0.0022 bar gauge is the velocity head pressure. Now vapor pressure is 0.05 inch of water column. So now converting into pressure, Vp is equal to density of water into G into H. So 10 to the power T is the density of water into 9.81 G into 0.05 inch. So converting 25.4 millimeter into multiplying 10 to the minus 3 is for meter. Now dividing 10 to the power 5 is for bar gauge. So PVP is equal to 0.001 bar gauge. Pipe friction strain pressure loss. Suction strain pressure loss is given, that is 0.02 bar gauge, and pipe and valve friction loss is 0.003 bar gauge, calculated separately. So we have made separate video for how to calculate the pressure loss, so through which we can calculate it, which is coming 0.003. So total pressure loss PF is equal to 0.003 plus 0.02, which is coming 0.023 bar gauge. So net positive suction head pressure available is equal to P plus PR plus P plus PV minus PVP minus PF. So putting all this value, it is coming as 0.82 bar absolute. So calculation summary. Flow is given 400 liter. P is this 1.013. Reservoir pressure is, after converting in bar, minus 0.10. Height of pump from reservoir is minus 2. Friction losses after adding 0.023. Vapor pressure 0.001. Density 850 kg per meter cube. So after this, it is coming 0.82 bar absolute. So with this, I have finished my discussion. Hope you like this. Please subscribe my channel, like it and share it, so that you will get the new videos. See you in the next discussion. Till then, bye bye. Thank you.